Alright, we're going to use 57 1/4 to solve fixed elevation sets. This problem with no math. We have a T rolled into an elevation change of 3 inches here. 8-inch full-size T. Takeoff of the T, 7 inches. Elevation change is 3. Should have this page. It has 7 steps with no math. We'll walk you right through it. Eight-inch pipe, 3-inch set. Using a T. 45 will not work. When you're all done, your layout will look like this. We'll achieve 19.4 angle of fitting. So once again, 8-inch pipe, 7-inch takeoff for the T, and we have a 3-inch elevation change. Step 1, draw line AB 57 1/4 inches long. Step 2, draw line AC 57 1/4 inches long, perpendicular to line AB. Step 3, draw an arc from point B to point C. We'll call this D arc, and the arc will have a radius of 57 1/4 inches. That arc will measure 90 inches, equaling 90 degrees. Step 4, draw E arc. This arc will have the radius of the takeoff of the 90. In this case, we're dealing with 8-inch pipe, so it should have a radius of 1 foot. Once again, here's your problem. Step 5, draw a line FG. This line comes down from the center line of the fitting. That is your set dimension. 3-inch set. Step 6, rotate the square down towards FG line. When 7 on your tongue hits FG line, stop. This is representing your T. This side here is representing your radius of your 90. This line here is your set dimension. Three-inch set. Step 6. Now we can stop. We've reached that point. You can see the crosshairs, center of the T is exactly over our set dimension. This has to remain at 12. 7 for your T. 1 foot represents the radius of the fitting that we're cutting. Those are your constants. Take the side of the square that was pivoting on point A and project it out to D arc. We'll call this point H. Measure the distance along D arc from point C to point H. In this case, we'd have 19.5 inches. That will equal a 19.5 degree fitting. No math. Angle of fitting 19.5 welded to T equals 3-inch elevation change.